Equal payment capital recovery amount. In this type of investment mode, the objective is to determine the equivalent amount A that should be recovered at the end of every interest period till the end of nth interest period for a loan P which is sanctioned now at an interest rate I compounded every period. The cash flow diagram of this situation is, we have a timeline. A loan amount of P has been taken today, that is at time t equal to 0. For this loan, how much equivalent amount we are supposed to repay back to the bank at the end of every interest period till the nth interest period. The mathematical representation of this statement is, with known value of P and unknown A, I interest rate and N interest period. The factor A by P, I, N is called equal payment capital recovery factor. The formula to obtain equal payment capital recovery amount is, A is equal to P into I into 1 plus I to the power of N divided by 1 plus I to the power of N minus 1. Here the value of I is in terms of decimals.
Now we'll solve a problem on equal payment capital recovery amount. If Mohan deposits rupees 25,500 into a savings account which earns him 9% interest per year, what uniform annual amount could be withdrawn at the end of each year for 15 years so that nothing would be left in the account after 15 withdrawal? So it's a very interesting question. So let's look into what exactly they have asked. Mohan wants to deposit 25,500 rupees into his savings account, and for this the bank gives him 9% interest rate. Now Mohan wants to withdraw this amount at the end of every year from the next year up to 15 years. So we are supposed to determine how much amount Mohan can withdraw from his account every year for next 25 years. So that is what we are supposed to determine. So we'll solve this problem and see how much Mohan can withdraw. Now the given data. Since Mohan is depositing 25,500 rupees today, therefore this will be the present value of Mohan's investment. So present value which is capital P is equal to rupees 25,500. Next, interest period which is N is equal to 15 years. Interest rate which is I, which is equal to 9%, or it is 0.09 in decimals. Now we'll draw the cash flow diagram for this particular situation. So you have the time scale and you have cash inflow and cash outflow. So it is for 15 years. So I'll draw the time scale first. Starting with 0, 1, 2, 3, 4, 5. This is 13, 14 and 15. Now Mohan is depositing the amount into the bank's account. Therefore, this will be the cash outflow. From the Mohan's account, the money is depositing into bank's account. So value of P, that is the present value, is rupees 25,500. Now he wants to withdraw the amount from the bank's account and put it into his account for 15 years. So from bank account he wants to put that money into his account. Therefore it is the cash inflow. And this cash inflow he wants to withdraw every year up to 15th year. So every year he wants to withdraw a constant sum up to 15th year. So this is the constant value which we are supposed to determine. This is the annuity value. This is the unknown which we need to determine. Now we will calculate what is this annuity. The annual equivalent which is the annuity, capital A, is equal to present value multiplied by I into 1 plus I to the power of n divided by 1 plus I to the power of n minus 1. So this is the equation to determine the annual equivalent, that is the annuity. I'll substitute the values into this equation. The present value is 25,500 multiplied by I is 0.09, 0.09 multiplied by 1 plus 0.09 to the power of n is 15 divided by 1 plus 0.09 to the power of 15 minus 1, which is equal to 25,500 multiplied by, we'll solve this particular term and determine what is this value. Okay, 0.09 multiplied by 1 plus 0.09 to the power of 15 divided by 1 plus 0.09 to the power of 15 minus 1. This gives us 0.124, which is 0.124. So which is equal to, we'll multiply it with the present value, which is 25,500 multiplied by 0.124, which is going to get as rupees 3,162, which is the annual equivalent. Therefore, Mohan can withdraw rupees 3,162 rupees up to 15 years if he make an investment of rupees 25,500 and banks give him 9% interest